Okay, so in this diagram, let x represent the side which is perpendicular to the river, and y represent the side of one of the enclosure which is parallel to the river. And the total fencing available is 720 yards. So I'm going to write down the fencing equation. That is, we have to fence along this side and this side, as well as this side. So it's basically 4 times of the side which is perpendicular to the river. So we put 4x plus we will also have to fence along this side which is 1y, and this side which is 2y, and also this side which is 3y. So this is the fencing equation, and this should equals 720. So we get 4x plus 3y equals 720. Now let's write the area equation. The area of the total area of this complete rectangular enclosure is this is width times the height or the length. We say that this is the length of the rectangular width, and this is 3y. So this is x times 3y represents the area. I'm going to write down this as A equals x times 3y. Now I can replace 3y from this fencing equation. So this implies 3y equals 720 minus 4x, which I'm going to write down here. So therefore this becomes x times of 720 minus 4x. Let's write down this as a function of x. So we have the area function as a of x equals x times of 720 minus 4x. In fact, we can keep this simplified by distributing the x. So I'm going to distribute the x into the two terms inside the bracket. So therefore this becomes 720x minus 4x squared. So this is the area function which we have to maximize. Okay, so now we are going to maximize the area using the first derivative and second derivative test of calculus. In first derivative test, we have to let the first derivative equals 0, and we have to solve for x from this equation. So first, I'm going to find the derivative of this area function, and this gives a prime of x. This is basically a prime of x, and this equals the derivative of 720x is, we put the constant 720, and the derivative of x is 1 minus I put the constant 4 as it is, and the derivative of x squared is 2x according to the power rule. So let's simplify this. So we get a prime of x, this equals 720 minus 4 times 2x is 8x. And now we have to let a prime of x equal to 0. So I'm going to replace a prime of x equals 0 and solve for x. So this gives 0 equals 720 minus 8x, and this implies we can now solve for x. So therefore 8x equals 720, and this implies x equals 720 divided by 8, and this equals 90. And this x is in yards, so we say that this is in yards. It is 90 yards. So basically, this is the critical point of the area function, and we have to double check if at this critical point the area is maximum. So for that, we have to do the second derivative test. So we find the second derivative of the area function. So I consider the a prime of x and find its derivative, which gives the second derivative. So we write a double prime of x, and this equals the derivative of 720 is a constant, so it becomes 0 minus 8 times of derivative of x is 1. So it is basically 8 times of 1. And this gives negative 8. And this is always less than 0. Also, it is independent of x. So there is no way that we can plug in this critical point into this function. Even if we plug in, it's always going to be negative. So according to the second derivative, we know that if the second derivative is less than 0, it is a point of maxima. So it is a point of maximum. That means we can now say that at x equal to 90 yards, the area is maximum. Area is maximum. So we have verified that at this critical point, this area of this field is maximum. And this means we can utilize this dimension, that is x equal to 90 yards. We'll find the y, that is other side of the enclosure. using this equation, that is 3y equals 720 minus 4x. So I'm going to determine y from that equation. Let me copy that. We have 3y equals 720 minus 4x. Let me plug in x equal to 90 here. So 3y equals 720 minus 4 times of 90. And this gives 720 minus 4 times 90 is 360. 720 minus 360 is 360. That is 3y equals 360, and this means y equals 360 divided by 3, and this equals 120. And remember that this is in yards. So we found the corresponding y, which is 120 yards. But since we have to give the answer in feet, we'll use the conversion, that is 1 yard equals 3 feet. Therefore, we see that x, this equals 90 yards, and this equals 90 times of, replace yards by 3 feet, so it becomes 90 times of 3 feet, and this equals 90 times of 3 is 270 feet. And similarly, y equals 120 yards. We convert this to feet by multiplying by 3, that is 120 times 3 times of feet, and this equals 120 times 3 is 360 feet. So therefore we see that the side perpendicular to the river, x represents the side perpendicular to the river. So we see that the side, I write down this perpendicular like this, using the geometry notation, side perpendicular to river, and this equals 270 feet. And then the side parallel, I write down like this, to river, and this equals 360 feet. So we determine the two sides of the enclosure.